2017 is the culmination of many years' discussions and hopefully will soon pass the Senate and House, and it perhaps will pass the Senate tomorrow. This legislation has two goals. First, it reiterates the importance of maintaining NASA's continuity of purpose. The National Research Council's Pathways Report, the Aerospace Safety Advisory Panel's recent reports, and numerous outside advisory groups and associations have all highlighted the significance of continuity. Without it, our space program will be left adrift and rudderless. Second, the bill allows the President to introduce a fiscal year 2018 budget request that reflects his priorities. With a fresh perspective, the White House will be able to work with the new Congress to implement the goals and initiatives necessary to continue our leadership in space. Our hearing today provides an opportunity to understand fundamental challenges before the new administration and Congress, and we will explore possible directions for our space program that will benefit and inspire the American people. Now that concludes my opening statement, and the gentlewoman from Texas, Eddie Bernice Johnson, is recognized for hers.
Thank you very much, Mr. Chairman, and good morning to all. I want to welcome all of our distinguished panel of witnesses and thank you for your service to the nation. I'd like to welcome our recently appointed new members to the committee, and most especially our new ranking member, Dr. Berra. This morning we will be discussing NASA, whose inspiring mission is nothing short of reaching for the stars. Mr. Chairman, dreaming big is what propels our nation to achieve lasting accomplishments. We all want our children and our grandchildren to believe in dreaming big and, yes, in reaching for the stars. NASA provides tangible evidence that we can do just that. Over the past 6 decades, NASA has sent humans to the lunar surface, robotically explored all the planets in the solar system, landed and operated rovers on Mars, monitored Earth and its systems, and studied the sun and looked deep into the universe. NASA has led the multi-nation International Space Station Partnership and has supported continuous human operations on the International Space Station for over 15 years. In addition, NASA has made significant progress in demonstrating the use of commercially contracted services for cargo resupply of the ISS. And NASA anticipates that the ISS commercial crew transportation services will begin within the next few years. NASA continues to follow the priorities of the National Academy's decadal surveys for its service program. For example, the James Webb Space Telescope, scheduled for launch in October 2018, will enable us to examine the first light after the Big Bang to the formation of galaxies, stars, and planets. I also want to recognize NASA's Earth Science Program, which has a long history of space-based observations in support of research to better understand our Earth systems and our changing climate. In addition, NASA carries out aeronautics research, which has been vital to the growth and safety of America's aerospace industry. Today, NASA is making steady progress on developing the Space Launch System, the Orion spacecraft, and the Exploration Ground Systems, the key systems that will enable us to once again send our astronauts beyond low Earth orbit and eventually to Mars. And as important as these activities are to advancing our priorities in space and aeronautics, they are no less important to us here on Earth. Advances in human health research and medical diagnostic tools, materials, and advanced technologies developed through the space program have all helped improve our daily lives. However, we cannot take NASA's incredible achievements or the benefits they provide for granted. They will not continue without a sustained commitment of vision, resources, and support. It is clear that the challenge ahead of us is to provide NASA with stability and sustainability so that it can carry out the challenging tasks that our nation has given it. We can get to Mars, but we need a plan to do so that is sustainable over multiple decades. We can answer the difficult question of whether there is life in the universe by continuing to support the scientific investigation of our solar system and beyond. I have no doubt that working together, we can enable NASA to these things and more. However, we must be careful not to undo NASA's progress by changing directions with every new administration. Simply put, we must commit to staying the course. Mr. Chairman, at a time when much of our national discourse revolves around what divides us, we can look to our space program as something that unites us. Well, we have a lot to discuss this morning, and I look forward to our witnesses' testimony. I also look forward to working with you, Mr. Chairman, our colleagues on the committee and the new administration to ensure that we give NASA and its partners the stability, sustainability, and resources needed to continue our leadership in sciences, aeronautics, human spaceflight, and exploration. I thank you, and I yield back.
Thank you, Ms. Johnson. And the gentleman from Texas, Mr. Babin, the chairman of the Space Subcommittee, is recognized for his opening statement.
Thank you, Mr. Chairman. Good morning. I'd like to welcome you all here today for a very important discussion on where NASA has been and where it is and where it will go. I find it difficult to imagine a more qualified panel of witnesses with more personal insight and experience than the one before us today than Dr. Schmitt, General Stafford, Dr. Stofan, and Mr. Young. I want to thank you very, very much for taking your time to come out from your busy schedules to be with us this morning. America's civil space program is nearing its 70th anniversary, and in the 7 decades since NASA's birth, astronauts have walked on the lunar surface, spacecraft have ventured out into the interstellar void, telescopes have discovered thousands of planets orbiting other stars in our galaxy, but those exciting achievements were not free. It is very difficult to explore a universe of infinite wonder with a finite budget. We must prioritize our visions and destinations in a way that reflects responsible stewardship of American taxpayer dollars. Fortunately, the election of a new administration and the start of a new Congress has given us the important opportunity to think about our space program and consider bold new directions in the future for our space program. For instance, should we return to the moon? How can we ensure that the progress made on deep space exploration capabilities, like the Space Launch System and the Orion, continues in a fiscally responsible manner? Can public-private partnerships and international collaboration augment taxpayer investment? How would those partnerships be structured to ensure safety and attract private sector contributions and provide value to the taxpayer? Can we both extend ISS operations past 2024 and conduct deep space exploration without significant increases in NASA's budget? NASA's hard work over many decades is on track to provide the nation with the tools it needs to make a bigger, bolder future in space. And now is the time to start talking about what that future will look like. I hope that our witnesses here today can help make that conversation as lively and as vibrant as possible. Our continued leadership in space is not just about exploration. Our national security, our international standing, and economic competitiveness all depend on our leadership in space. I couldn't be more excited to discuss these crucial questions with today's witnesses, and I want to thank you all again for being here, and I look forward to your testimony. I'll yield back, Mr. Chairman.
Thank you, Mr. Babin. And the gentleman from California, Mr. Barr, the ranking member of the Space Subcommittee, is recognized for an opening statement.
Thank you, Mr. Chairman. And good morning and welcome to the distinguished panel. Listening to the chairman's description of the panel, it makes all of us feel like underachievers here. I also want to just take a moment to thank my Democratic colleagues for selecting me as the ranking member on the Space Subcommittee for this Congress. As a kid who grew up in Southern California in Downey, home of Rockwell International, much as my generation, the space program epitomized, the national pride that we had in America. The fact that, President Kennedy challenged us to dream beyond what we knew we could do, yet we set our minds to it, we focused on it, we recruited the best talent, and we went out and achieved it. And getting back to that pride is incredibly important. I think all of us remember waking up early in the morning to watch Apollo launches, holding our breath, watching Apollo-Soyuz, Skylab, the space shuttle. And we've got to recapture that imagination again. We've got to, as the ranking member said, we've got to dream big. And that's why SLS and Orion are so important. We don't know yet how we're going to go to Mars with human space travel and return. But the goal of imagination and dreaming and achievement isn't doing what you know how to do. It's about setting that goal, taking the talent that we have in America, and putting our minds to it. Yes, we have limited resources. Yes, we have other priorities. But we've got to get back to dreaming big. And it is that vigor that inspired a generation of kids to go into the sciences, to move forward. And if we want to continue that superiority in technology and American pride, the importance of our national defense, it was great to see in Dr. Stofan's opening remarks, for my home state of California, some of the work that NASA is doing in helping us manage water and address it. And it seems funny to be talking about a drought right now in this really wet winter, but what NASA does in helping us manage weather forecasting and so forth is incredibly important in national security. So, I am deeply honored to be the ranking member. I am, the members of this committee do not, this is not a Republican or a Democratic issue. This is about national pride and leading the way. And I don't want an American space program that follows. I want an American space program that moves us forward and leads and works with the international community to continue to go to that next frontier. In my own district, we've got an Aerojet Rocketdyne facility, and when I visit the workers out there, and when I listen to the President talk about bringing manufacturing jobs back to America, it's those types of jobs that are not the jobs of the last century, but the jobs of the next century. And it is pretty amazing the work that they're doing. And if we make the right investments, we can lead the way once again and lead the 21st century space program. So, thank you to the distinguished panel. Thank you to the chairman for calling this hearing, and I look forward to working in the 115th Congress to make this a reality.
Thank you, Mr. Bear. Our first witness today is the Honorable Harrison Schmitt, an Apollo-17 astronaut and former U.S. Senator from New Mexico. His career as a geologist has taken him around the world and beyond. In 1965, he was selected as a NASA scientist astronaut. In 1971, Dr. Schmitt was assigned as a lunar module pilot for the Apollo-17 mission. He is the first and only scientist to walk on another celestial body. He then went on to serve in the U.S. Senate for 6 years, and he has also served as chairman of the NASA Advisory Committee. With the sad passing of Gene Cernan, Dr. Schmitt is the last person alive to walk on the moon. Dr. Schmitt has a Bachelor's of Science from the California Institute of Technology and his doctorate in geology from Harvard University. I'll now recognize the Vice Chairman of the Science Committee, the gentleman from Oklahoma, Mr. Lucas, to introduce our next witness.
Thank you, Mr. Chairman. And it is my privilege to introduce Lieutenant General Tom Stafford. General Stafford was born and grew up in Weatherford, Oklahoma, a town in my district literally just down the road from my hometown of Cheyenne. He was selected to be a part of the 2nd astronaut class as a member of the Air Force in 1962, where he began an amazing career. He commanded Gemini 6 and Gemini 9 before heading the mission planning analysis responsibilities for the Apollo project. And as commander of Apollo 10, he performed the first flight of the lunar module 9 miles above the lunar surface and designated the first lunar landing site. Obviously good radar and photography there, General, as successful as that was. Following the Apollo program, he worked at the NASA Manned Spaceflight Center and logged his 4th space flight as an Apollo commander of Apollo-Soyuz test project mission in 1975, which helped end the space race. Since coming back to Earth, General Stafford worked as the Deputy Chief of Staff for the acquisitions at the Air Force. He initiated the F-117A stealth fighter, wrote the original specifications for the B-2 stealth bomber. He served as an advisor to the NASA administrators over the past 20-plus years and has personally helped the various vice presidents assess NASA's capacities and objectives. And he's currently chairman of NASA's Advisory Council Task Force for the International Space Station's safety and operational readiness. And General Stafford, I believe I can speak on behalf of the whole committee and certainly every one of our fellow Oklahomans. We are honored that you are with us today and this morning, and we look very forward to your comments, and as always, thank you for your service. Yield back, Mr. Chairman.
Thank you, Mr. Lucas. Our next witness, Dr. Ellen Stofan, served as NASA's chief scientist from 2013 to 2016. There she served as principal advisor to the NASA administrator on the agency's science-related strategic planning and programs. As a scientist, her research has focused on the geology of Venus, Mars, Saturn's moon Titan, and the Earth. Dr. Stofan holds a bachelor's degree from the College of William & Mary and a master's and doctorate degree in geological sciences from Brown University. Our last witness today is Mr. Tom Young, and he is the former director of NASA's Goddard Space Flight Center, the former president and COO of Martin Marietta, and former chairman of the Science Applications International Corporation. He began his career with NASA at the Langley Research Center in 1961 and became director of the planetary program at NASA headquarters in 1967. Mr. Young was recognized with NASA's highest award, the Distinguished Services Medal, for his role in the Viking project, the first time any country has successfully landed a payload on Mars. Mr. Young earned both a bachelor's degree in aeronautical engineering and a bachelor's degree in mechanical engineering from the University of Virginia and a master's of management degree from MIT. We welcome you all and certainly recognize your collective expertise. And Dr. Schmitt, will begin with you.
Thank you, Chairman. I am an explorer. Freedom in America uniquely enhances the human drive to explore beyond familiar and or unknown boundaries. Exploration is in our blood, as has been indicated by your statements. From the founders' foray into constitutional government, to entrepreneurial enhancement of our pursuit of happiness, to Jefferson and Lewis and Clark's opening of the American West, and yes, to Eisenhower and Kennedy's bold initiatives leading to Armstrong's first small step on the moon. Now the moon and Mars and deep space beckon new generations of young Americans, and I emphasize young. We would ignore their call at our peril. A program for Americans to land on Mars would be a remarkable and historic answer to that call. Such a landing, however, will not be easy. Mars has just enough atmosphere to cause trouble on entry, but not enough to help. The great distance between Earth and Mars means crews will not have mission control to help in critical operations. Gravity on Mars may or may not help astronauts adapt physiologically. Long transits to Mars may require artificial gravity and/or fusion propulsion, and definitely require heavy shields of water for radiation protection. The capability to launch 100 metric tons to Earth escape velocity may be required. At least 2 generations of young engineers, scientists, and skilled workers must relearn how to deal with the challenges and risks of deep space. To meet these challenges, I am convinced that the moon is a necessary stepping stone with great geopolitical and scientific value of it in its own right. Only 3 days away rather than many months, the moon provides necessary resources, engineering verification, operational training, physiological insights, private sector partnerships, and the immediate geopolitical high ground. If the United States returns to deep space, Congress can gain valuable lessons from the Apollo Cold War space effort. The keys to success for the Apollo program were a sufficient base of technology and aircraft and spaceflight experience to begin, a large reservoir of patriotic young Americans and skilled workers, the Sputnik generation, a pervasive environment of national unease, the catalytic events of Sputnik and Yuri Gagarin's orbital flight, an articulate, persuasive, and patriotic president and Congress, a congressional and White House commitment to about 100% management reserve of funding so schedule could be maintained in the face of unknown and unknown problems. Tough, competent, disciplined, courageous managers, and possibly as important as anything, a working environment of liberty. All these keys must accompany a Moon, Mars, deep space initiative, but also include, in addition today, improved education in STEM skills and critical thinking, substitution of China's ambitions for the Cold War stimulus of the 1960s, a permanent national commitment to deep space exploration, maintenance of an average workforce age of less than 30 years, and elimination of an aversion to taking necessary risks. As detailed in my submitted testimony and on the Americans' Uncommon Sense website, a focused Apollo-style management system will be needed. This system must stay young, stay lean, and stay risk-takers. Once the decision to go back to the Moon and on to Mars is made, the sole focus of civil space management should be to do just that. With a well-managed Moon, Mars deep space program, having sustained annual funding levels of about $20 billion per year, including 30% management reserve, the following milestones should be possible. Return Americans to the Moon surface by 2025, lunar settlement by 2030 with public and private capital funding partnership, lunar resource production by 2035 with private capital funding and management primarily, fusion-powered interplanetary booster also by 2035, Mars crew landing by 2040, and I believe Mars settlement by 2045. That's a big agenda. In conclusion, returning to the Moon will increase significantly the probability of success of a Mars landing and exploration program, and to maximizing its scientific returns. Because of the multi-decadal nature of such an effort, such a return to deep space exploration requires the unequivocal and sustained commitment of the nation, even more so than was required for the Apollo program, again because of its multi-decadal aspects. Finally, if the decision is to move quickly to reassert American dominance in space, we are, I believe, well positioned to do so. The geopolitical environment facing freedom today is as critical as that which faced Congress in the Eisenhower and Kennedy administrations prior to Apollo. Our current technological foundations actually greatly exceed those of May 1961, having been vastly expanded by the nation's public and private sectors. Development of the Space Launch System is well ahead of Saturn V development at a comparable time, thanks to leaders in Congress, such as yourselves, and to leaders in NASA. The Orion spacecraft is in test rather than being just a sketch on a blackboard. Constellation's Altair lunar design progressed well beyond early concepts of the Apollo lunar module. Understanding of human physiology in space has been greatly advanced by use of Skylab, the shuttle, and the ISS. Unlike the 1960s, the private sector is well positioned to support as well as to partner with the federal government. I believe, Mr. Chairman, Congress and the administration should move America back into deep space sooner rather than later. Thank you for your attention. I look forward to comments of my colleagues, and I would be happy to answer any questions that you or the committee may have.
Thank you, Dr. Schmitt. And General Stafford. But, make sure your microphone is on there.
Got it.
Okay.
Checklist. Mr. Chairman, Ranking Member Johnson, and members of the committee, I'm honored to appear before you today to discuss our nation's space program. In my opinion, the timing and the subject of this hearing are perfectly chosen. One of the key issues confronting the new Congress and the new administration will be how to go forward with restoring Americans' preeminence in space after what, frankly, for nearly 8 years has been lost opportunities. And getting the program back on track is so important. The next task will be to ensure the stability of the program. We have in recent years seen all too clearly the consequences of failure to carry out the long-term objectivities. The changing of major programs with the change of new administrations has been detrimental to the nation's space program. NASA's past is one of the nation's crown jewels, and one of the things that has made America great. It is a wonderful projection of what I would term soft power to the rest of the world. That encompasses 9 Apollo missions to the moon. 6 of those were landings on the moon. We have 7 robotic spacecraft landing on Mars, the Hubble Space Telescope, and the first rendezvous and landing on a near-Earth asteroid, the robotic reconnaissance of every planet in our solar system, and the development of the space shuttle, and with our international partners, the building and the operations of the International Space Station. I and my colleagues on this panel have had the incredible privilege and the good fortune to be part of that history, Mr. Chairman. Unfortunately, it is history. NASA's present today does not do justice to its past. Many of our greatest achievements are no longer to be seen in flight, but rather to be found only in museums. We have abandoned plans to return to the moon, establish a lunar base, and instead, just recently, start to talk, but only talk, about going one day to Mars. The next flagship science mission that we will launch, the James Webb Telescope, was started during the Bush administration, with nothing comparable initiated during the 8 years of the previous administration, with the exception of a wonderful congressional initiative to build the SLS and the Orion spacecraft. And I said last night at the meeting that the members of this committee and the similar committee in the Senate should be congratulated for taking the initiative to say that America should go forward, and you all did a great job, just a wonderful job. I know it was Bill Nelson was a leader for the Democratic side, Kay Bailey Hutchison. Over here we have Mr. Gordon and Ralph Hall, whose picture I see on the wall there, great leader. It worked so good, and a lot of the staff, like Robert Overman, I recognize, and many others. It was such a great effort by the Congress of this committee in 2010 that set the umbrella that we're now proceeding and going forward. And we need this future will return us to the moon and then go on to an expedition to Mars. The SLS can be useful for many large robotic spacecraft to the outer planets and may be useful to the Department of Defense. And we've done a lot of studies, and in the period of 1991, I was asked by the Vice President to put together a large team to study how to go back to the moon, go on to Mars in a way that is faster, better, and I'll use the word less cost, not cheaper. And so I gathered 45 people full-time. I had the commander of the Space and Missile System put together 150 part-time. We had inputs from academia, industrial firms from all over the United States. And then for nearly 12 months we studied, and finally the Vice President and I had a joint press conference in the White House and produced this book, which is the inputs of thousands of people, called America at the Threshold, still regarded by some as a Bible, and a foundation. You can use variations of it, but that will take you back to the moon and on to Mars. And I know it's not been fashionable to talk about the moon, but the moon is important. And we said in one of our architectures that we would go there and learn enough, from the environment and do simulations too with Mars things, not to take up too much of the funding, but enough to go there and then on to Mars. Okay. Thank you, Mr. Chairman.
Thank you, General Stafford and Dr. Stofan.
Thank you for inviting me before this committee today. As the chairman remembers, I was delighted to come and speak with you about life in the universe in 2015. Today, I want to share my optimism about where NASA currently stands and where it's headed. Over the next few years, I hope to join members of this committee to watch American astronauts launch from Florida aboard American spacecraft, feel the roar of the largest rocket since Apollo leave the ground, have my perspective of the universe changed by data from the James Webb Space Telescope, and have people's lives improved here on Earth by the continued observation and study of our own planet, and be much closer to answering that question, are we alone? NASA's planetary Earth science, astrophysics, and heliophysics programs continuously rewrite textbooks with their discoveries. These areas of science are deeply connected and are leading us to discover an Earth-like planet around another star. NASA's Kepler Space Telescope has found over 3,000 planets around other stars, and telescopes launched in the coming years will further this search. Which brings me to Mars. Mars is the most likely place beyond Earth to have harbored and may still harbor life. Other targets include Europa, Enceladus, and Titan. But Mars is the closest, the most accessible for exploration, and the most like our own Earth. Finding fossil evidence of past life on Mars is not going to be easy, and I strongly believe it will take Mars astronauts to find proof of life. When I started as chief scientist, I was moving houses, and I found an old newspaper interview with my father that he did when he became head of the space station in 1986. He talked about how the space station would lay the groundwork for humans to get to Mars in 20 years. I read this not long after having given a speech saying the exact same thing. Mars will always remain 20 years in the future without bipartisan support and the commitment to make it happen. It can be done without major increases in budget and without revolutions in technology. It just needs focus, constancy of purpose, and continued leadership. NASA has a sustainable plan to get humans to Mars orbit by 2032 and land thereafter. This plan is built upon the research NASA does on the space station to prepare for longer duration spaceflight and NASA's development of deep space capabilities. The next step is a habitat in lunar orbit in the mid-2020s to learn about the higher radiation environment and finalize development of long-duration life support systems. If international partners or the private sector want to go to the surface of the moon, as the commercial sector is well on its way to doing, NASA is already supporting these efforts. In both low Earth orbit and the surface of the moon, the 2020s will be the decade of NASA moving out and the private sector moving in. By 2032, we'll be ready for that first human round-trip mission to Mars, with the surface landing to follow in the late 2030s. Unlike past plans, this plan is sustainable as it assumes a level of spending consistent with post-Apollo reality. Should Congress want to up the relative spending, this timeline could be accelerated. Mars is the goal for human exploration. It is key that we keep our eyes on this prize, doing things we have never done before, pushing the limits. This is the proper role and should be the focus of NASA. When nations try to do great things, tough things that no one has done before, they move their country forward economically, strategically, inspirationally. But it's important to remember that the only planet we can actually live on is this one. From space, we are able to collect deep and continuing data sets of Earth that are directly beneficial to our economy, our national security, and to each one of us every day. Data gathered from NASA's Earth-observing satellites and aircraft, coupled with NASA's support of fundamental research and analyses of these data, enable us to better understand and predict our weather, make better land use and urban planning decisions, and respond to natural disasters and wildfires. Satellite observations of crops help us predict food security needs, not just in this country, but around the world. NASA data are helping us understand the rapid rate of change we see from melting sea ice in the Arctic, the loss of ice in Greenland and Western Antarctica, changing patterns of vegetation, and rising sea levels. Water is a precious resource and a potential source of world conflict. Our satellites today are giving us an unprecedented view of the global water cycle. These data help farmers plan how to water crops, water resource managers plan for and deal with too much or too little rain, and warn us of possible droughts or floods. As chief scientist, I spoke to school kids here and around the world. NASA truly does inspire the next generation. They see NASA as a shining example of American ingenuity and leadership, American can-do. NASA has accomplished great things and now reaches to do great new things, find life on other worlds, walk on the surface of Mars, use our space data to help sustain and prosper life here. It just takes commitment and focus. With your support of NASA, you don't have to wait for the future to happen. You can create it. Thank you.
And thank you, Dr. Stofan and Mr. Young.
Thank you, Mr. Chairman. NASA's accomplishments during the 6 decades of its existence have been extraordinary. It's hard to imagine a public or private sector organization that has accomplished more given the level of difficulty of the NASA endeavors. Included in the array of accomplishments are observations that have revolutionized our understanding of our sun and planetary home, landers and rovers on the surface of Mars, robotic visits to all the planets of our solar system, telescopes that have looked billions of years back in time and also have discovered hundreds of planets around other stars, humans walking on the surface of the moon, and the development and operation of a space station that is a technological marvel. Truly, NASA has repeatedly turned the perceived impossible into reality. NASA's accomplishments have filled our books and electronic systems with new knowledge about our sun, Earth, our solar system, the universe, and humans operating in space. NASA has been a source of enormous national pride and international prestige. NASA has inspired our youth as well as people of all ages. When we make the observation that great nations do great things, the NASA contributions are high on the list of great things. NASA has done its part in making our nation great. One of the more impressive accomplishments of NASA has been the human exploration program, specifically humans walking and riding on the surface of the moon while exploring and enhancing our scientific understanding of our nearest neighbor. While the lunar endeavor was spectacular, it also highlights a disappointment that no boots-on-the-ground human exploration venture has been accomplished since Apollo-17, 44 years ago. We have the opportunity to rectify this disappointment in the next couple of decades. The enormous capability that has been developed from the multitude of successes as well as disappointing failures is often overlooked when assessing the accomplishments of the last 6 decades. NASA has an enormous bank of knowledge, expertise, and experience largely resident in the people of NASA. It would be wrong to equate the accomplishments of the last 6 decades to NASA alone. The U.S. aerospace industry, with implementation capabilities second to none, has been an incredible partner. The industry has continued to develop its capabilities to implement the most challenging of endeavors. The third leg of this national capability is the depth of talent that resides in our laboratories and academic institutions. I believe the reason for the remarkable success of the last 6 decades is that we have fully utilized the continuity of expertise resident in NASA in combination with the implementation capability of industry and the talent and capabilities in our laboratories and academia. Space is a one-strike and you're out business. It takes the absolute best of all sectors to assure success. Our space initiatives are focused on exploration and science. To maximize our exploration and scientific results also requires our absolute best. These lessons learned will be critically important to the future of NASA. So where is NASA today? The trend of challenging endeavors with anticipated incredible results continues unabated. The James Webb Space Telescope, SLS, Mars 2020 is the first step in returning samples from the surface of Mars to Earth, and Orion are but examples. In addition to rigorously implementing the approved NASA program, a most important responsibility is developing a strategy for the future. This is currently critical because the challenges and opportunities are large and significant. With exceptional leadership, focus, commitment, and support, the future can be even more rewarding than the past 6 decades. It is also possible that we can spend a lot of money and accomplish little. There is a set of great questions that can guide our thinking about the future. Are we alone? What is dark energy and dark matter? Is it possible and practical for Mars to be a lifeboat or a second home for the human race? There are certainly other great questions, but these are opportunities to start the discussion. I believe we can answer each of these questions in the next few decades. I suspect we have all looked at the night sky and wondered if we're alone, or if we have neighbors waiting to be discovered. The fact that we don't understand 90% of the universe says the opportunity for awesome discoveries awaits us. In discussing the NASA future, I'll separate my comments into science and human spaceflight. The science element is well planned and focused upon the highest priority endeavors. The National Academy's decadal surveys are well done, with broad participation of the scientific community. NASA effectively utilizes the decadal surveys to establish direction for the science enterprise. The current and future strategic state of human spaceflight is cloudy. In current NASA budgets, approximately $9 billion is allocated to human spaceflight. Over the next 2 decades, that accumulates to approximately $180 billion, which should support significant accomplishments. My view is that there are too many potential paths competing for the available resources, making it imperative that difficult program decisions be made. About half the current budget is allocated to low Earth orbit endeavors, which consist of the International Space Station, commercial cargo, and commercial crew. The other half of the budget is for human exploration, which includes SLS and Orion. A $4.5 billion budget is clearly inadequate for a capable human exploration program. A choice must be made, and made soon, between LEO and exploration. Additionally, there is discussion of NASA leading or being the catalyst for commercializing LEO. There are also plans for a cislunar space endeavor of approximately a decade duration. Debate continues as to whether the moon or Mars should be the exploration objective. Are we going to have a credible human exploration program? Assuming the answer is yes, we need to focus our physical and human resources on making exploration a credible reality. Failure to decide between these competing options will result in significant resources being spent and could not have a credible exploration program. Mm-hmm. My personal conviction is the primary human spaceflight goal for the future NASA should be exploration with boots on the ground on either the moon or Mars. I believe Mars is the most compelling objective. I believe the commercialization of LEO should be the responsibility of the private sector, with NASA providing technological support, but not management or financial support. Above all else, a detailed plan for the human exploration program is mandatory. A future NASA focused upon the great questions, with a science portfolio guided by the National Academy's decadal surveys, and a human exploration program concentrating on the human exploration of Mars, can be responsive to the axiom that great nations do great things. NASA's future can be even more exciting and rewarding than NASA's extraordinary past. Thank you.
Thank you, Mr. Young. I'll recognize myself for questions, and Dr. Schmitt, let me address the first one to you. You set some great, worthy goals, landing again on the moon in, I think, 2025, landing on Mars in 2040, only 25 years from now. What does NASA need to do that it is not doing now to get to Mars by 2040 and land astronauts on that surface?
I think Mr. Chairman, I think the main demand to accomplish that would be to put together a management system in NASA that is comparable to what ultimately evolved for Apollo. That system would include an average age that's younger than NASA today. The young people provide that courage and patriotism and imagination that really made Apollo possible. During the Apollo 13 crisis, Gene Kranz did a survey when he had a moment of the ages of people in mission control, and the average age at that time was 26. The nuclear Navy keeps itself young. And it's well worth, I think, looking on how that's done. Of course, it's a military program, and they have different rules than the civil service. But still, I think it's important for the long-term future of NASA to find a way in which it can keep itself young.
Okay, good. Thank you.
That's one of many, but management is going to be the key, I think.
Thank you. General Stafford, just to take it to the shorter term, say the next 4 or 8 years, what recommendations do you have for Congress and NASA as to what we can accomplish in that time frame? And let me add that yesterday NASA announced, I don't know if you read it or not or heard it or not, but NASA announced that they are going to conduct a study about the very real possibility in 2 years of sending astronauts on SLS and do a Mars flyby. They're just conducting the study. They didn't commit to it 100% yet, but I'm sorry, moon flyby, not a Mars flyby. What do you think? That got your attention, didn't it? A moon flyby in 2 years with astronauts on SLS. But what do you think of that idea? What do you think we could be doing in the next 4 to 8 years?
Mr. Chairman, the one thing again is continuity and adequate management and budget resources. And it's so important, I think, that people understand why we need a big booster. And for the new members of the committees here to emphasize that when I lifted off to go to the moon, and when Jack Schmitt lifted off, the total mass was about 6.25 million pounds. And in 11 minutes, we put approximately 300,000 pounds into orbit. Or a little, I had about 138 metric tons, and Dr. Schmitt had a little bit more on his. And then we kicked out. And on the way to, then most of it was a third stage with the fuel in it. The useful pay, which was about 4.8%, only 4.8% of that giant booster. And what was the useful payload, the lunar module and the command module, was a third of that. So we had 1.6% that went on to do that mission, to land on the moon. So this is why you need a big booster. You'll see all different ideas. We'll take small ones and put them together and all this. Well, we've been through it and say we've studied it from A to Z. Doesn't work.
Okay.
We're started down the right path, and I think.
Good to hear. Okay, thank you, General Stafford. And Dr. Stofan, you have a special interest in discovering life in the universe elsewhere outside of our solar system, and I have a special interest in that as well. I think it's a fascinating subject. What are the prospects of discovering some form of life, vegetative, sentient, whatever it might be, elsewhere in the universe outside our solar system? And do we have any hope, say, in the next 10 years with any of our telescopes or next-generation telescopes of picking up spectra from an Earth-like planet, for example?
Well, as you know, we have all of the targets from Kepler of planets around other stars, some of which lie in the habitable zone. And then obviously we have the transiting, TESS, the Transiting Exoplanet Survey telescope that will launch in about 1.5 years that will, we think, find a habitable planet, a potentially habitable planet, about one a month for its 3-year mission. That means we're going to have a lot of candidates for the James Webb Space Telescope, which has the ability to look at the atmospheres of planets around other stars. So James Webb will hopefully start looking for gases like carbon dioxide, methane, oxygen, water, that would be potentially indicative of habitability. But it's really going to take that next generation of space telescope, I think, to get us from identifying potentially habitable worlds to being a lot more confident that that world is actually potentially inhabited. So for right now, I think our focus really needs to be on our own solar system, Mars, Europa, Enceladus, Titan, where we can really push this question of what are the bounds of habitability, what are the chances of life beyond Earth by really looking at our own solar system.
Right, and as you know, NASA has plans for Europa as well, too.
Yes.
With the indulgence of my colleagues, let me squeeze in one last question for Mr. Young, and it is this. Mr. Young, you mentioned the constraints of the budget. You said we have limited resources, all of which is true. So therefore, what can NASA do best? What can the private sector do best in order to maximize the use of our resources?
I have a couple answers to your question, which is a very good one. First off, I really believe we've got.
Will you pull the mic toward you just a little bit? Thank you.
Okay.
There.
I really believe we've got to make the hard decisions. We cannot distribute the limited budget over all of the possibilities that exist, even though they all have merits, and expect to accomplish them all. So we've really got to establish priorities, number one. The second thing is that having spent a bit of my life both in NASA and also in the private sector, I have some appreciation for both sides of the equation. NASA has enormous, what I call continuity of capability to apply to a given space exploration kind of an endeavor. Industry goes much more from project to project and has enormous implementation capability. And I think we need to recognize what the strengths that both groups bring to this particular problem. And when we're able to marry the enormous continuity of capability that NASA has and the implementation capability that industry has, we seem to really be able to accomplish an awful lot. When we choose to tie one or the other, one of their hands behind them and say, look, we're only going to use part of your capabilities, that's when we usually end up with not very satisfactory results.
Okay. Thank you, Mr. Young. That concludes my questioning, and I'll recognize the ranking member, Ms. Johnson, for her questions.
Thank you very much, Mr. Chairman. Let me thank all of you for your testimony. It's been very enlightening to me. And I guess my question now is, I'd like to hear from each of you what you would recommend that we focus on for the next few years. And if we choose to continue to focus on all aspects, the station as well as pursuing Mars, how much money do you think we need?
Congresswoman, that's a tough question.
Yes.
Because as I said in my oral testimony, and I believe very strongly that if you decide you're going to have a deep space human spaceflight program that includes the moon, Mars, and deep space itself, that needs to be a focus. And there are, I think, other ways in which we can implement the very fine programs that NASA has undertaken in the years largely since Apollo. But it takes management focus, I think, to make sure that you're going to be successful and to deal with the geopolitical realities that drive you in that direction.
Thank
And so I think the Congress needs to examine just what is going to be required legislatively in order to provide that focus.
Mm-hmm. Thank you. General Stafford.
Ms. Johnson, as pointed out by the chairman, we have so much money for the exploration. This includes the space station, other things, and we've answered a lot of questions that were identified, studied in other studies. One thing is how do you close the loop to reuse the air? Now, every human being here at sea level, average weight, uses about 2.2 pounds of oxygen a day. You need about 6 pounds of water a day. And then approximately 1.5 pounds of food a day. Probably some people get more than that. And, but the main thing is to recycle it. And the Russians started it. We started it really in Skylab. And now it's working very well on the space station. But remember, as I pointed out, that when Dr. Schmitt and I flew to the moon, our useful payload was 1.6% of what we lifted off with. So if you have a pound of 1.6 of oxygen, it's going to take 100 pounds of payload to start with, of gross weight to start with. So the space station has answered a lot of that. It's been up there for quite a while, and by 2024, to me, it should answer most of the questions that have been required. And also, we've determined with the, called the ARAD, Astronaut Exercise Resistant Device, how to keep the bone mass up, the muscles up, and we've really come a long ways. The station has really answered a lot of the questions. So that some of that money could be used to go forward.
Thank you.
I think the focus should remain more or less as it is, implementing the decadal surveys, supporting basic research and technology development as NASA does across its directorates, supporting aeronautics and the great support it gives to the aeronautics industry in this country, and to follow NASA's plan, ISS to 2024, support SLS and Orion, lunar habitat in the mid-2020s, Mars orbit in 2032. This is an achievable plan. And again, it more or less fits within NASA's existing budget. This does not require huge increases in budget.
Thank you.
I believe that if we continue on the current course with the multiple paths that we're on and the current budget, the committee hearing that'll take place 10 years from now will say what a disappointing decade we had, and that we will be negligibly closer to landing humans on Mars than we are today. So I think we have two real decisions to make. One is to narrow the number of paths and to focus on the highest priority item. The second is, you asked about resources, and this is always dangerous, and I haven't done a great analysis, but if I had to answer your question, if you want to keep doing what we're doing today, what do you need? $10 billion plus more. Per year.
Thank you very much. My time's expired.
Okay. Thank you, Ms. Johnson. I've always felt we ought to have a pen that says 1% for NASA, which would be doubling our current budget. The gentleman from Oklahoma, Mr. Lucas, is recognized for his questions.
Thank you, Mr. Chairman. General Stafford, you may not have been there on the first day of NASA, but you've been there in one capacity as an astronaut or a manager or an advisor since the Kennedy administration.
He was my boss for a brief period of time, too.
You're a lucky man. I bet he was thorough, too.
I was.
So, General Stafford, from your perspective, if you could expand for a moment, what are the things that we on the committee should be concerned about? What perils lie out there that we should be prepared to think about?
Mr. Lucas, we talk about human spaceflight. The number one criteria is safety, absolutely above all. And what concerns me is if NASA, we've set the criteria, we understand it, but yet at times it's gotten away from us, like those two accidents we had on the shuttle, the tragic fire we had early on in Apollo, but then we came back, then we had the Apollo-13, and we learned a lot of things. And we have all these strict requirements, and you violate those requirements, it can be a very bad day. That is one thing is my concern, is we have safety, and we have a rigid reinforcement all the way through for that.
Very good observation, General. Also along that same line, there are opportunities that avail itself, whether it's the moon or the asteroids or Mars or things a century on down the road. And there's lots of discussion in this day and time amongst members of the committee and the general public about NASA's role versus the growing industry, so to speak, how to maintain that balance. Do you have any observations on that?
Well, my portion, what the volunteer work I do now is the advisory committee for the International Space Station. So we just look at the mass, coming up, and there's been some failures, and we've had, but when they use the word commercial, I go back to my fortunate experience for about 30 years, and I've served on 14 boards on the New York Stock Exchange over this period of time, one in the American. So I think I understand what.
You have come a long way since Weatherford High School, yes.
So, thank you, sir. So well, what is called commercial to me is not really truly commercial. It's probably more subsidized. That's what Mr. Lucas, what I would say. But in other words, if you have commercial, you plan to make a profit, but where does the funds come from? Are you going to be able to sell this? Now, if it's a long-term thing, might be progress payments. But I don't really see it's pure commercial right now, the way it is.
Thank you, General. Dr. Schmitt, you have the unique perspective, not only being an astronaut, a scientist, but you've been a part of the legislative body. You have that other body.
The other body, yeah.
And that's the polite way to put it today, that other body. So you've seen the appropriations process from the inside. You've seen the budget process from the inside in the other body. Would you agree that we face certain challenges as a committee, trying to make sure that resources are properly allocated to do the things we need to do? I mean, you went through these struggles as a senator.
Yeah, no question about it, Congressman. The problem is political diversity. There is a great pressure to deal with many different things for many different constituencies. And I really think, again, that if we're going to focus on the geopolitical issue, we're going to have to truly focus. And everybody has to realize that there may be other ways to get the diversity, but the agency that is charged with going forward with human spaceflight is going to have to focus on that. And Congress, I think, in the House and Senate are going to have to focus and try to resist what has been going on, and that's this political diversity that has been asked of the agency.
Well, Senator, I wholeheartedly agree with you, and I acknowledge we have to make tough decisions. Matter of fact, when I leave this committee hearing, I'm going to a meeting of the Ag Committee where we're going to discuss what you should be able to do with your food stamps. It should be lively and exciting. With that, Mr. Chairman, I yield back.
Thank you, Mr. Lucas. And the gentlewoman from Oregon, Ms. Bonamici, is recognized for her questions.
Thank you very much, Mr. Chairman and Ranking Member Johnson, and to all of our witnesses today. I think this is the only committee in Congress where the biographical information is longer than the testimony. So really appreciate all of your expertise and your background. General Stafford, Russia has been in the news quite a bit lately. And there is much to be concerned about and investigated. But there have been other strained times in our relationship, and the space program has always stood out as a diplomatic success. It is vital that space exploration does not become a political issue between Russia and the United States. So what is your assessment of the current state of the Russian space program? We are, as of today, still relying on Russia for launching our U.S. astronauts to the International Space Station. Did you have any concerns about that or concerns about the reliability or quality of the launch vehicles or Soyuz at this time?
Well, Congresswoman, very good question. And I was fortunate at the height of the Cold War when each country had 6,000 or 8,000 nuclear weapons aimed at each other. We did the Apollo-Soyuz mission. And the Soviets and now the Russians, at times they were difficult as far as the negotiations. However, once they negotiated and signed up to the agreement, they lived up to it. And it worked out very well and set the background for the future shuttle Mir and the International Space Station. Now, they have recently had, well, over a period of time, I think 3 progress failures that have gone, or that booster. It's slightly different than what we fly with a spacecraft. Now, the first stage of the Soyuz booster, they've flown over 2,000 of them, and it's fairly reliable. It's in the upper stages where they're having the problems. However, it's a very rugged vehicle. It's landed in low hills and really mountains at times, something we haven't been able to do, and they can land on water. So And they have upheld their part of the agreement all the way through. And again, they are very much aware of safety criteria as we are.
Terrific. Well, thank you, and I think we can learn from history and what our countries have done in the past and maintain that relationship despite what happens in other spaces. So, Dr. Stofan, Oregon State University in my home state receives significant funding from NASA. The work they do helps inform important national activities, like you discussed in your testimony, like weather forecasting, ocean monitoring. What are some of the concrete examples of how Earth science missions and research have benefited the American people and our economy? And then I also want to ask you, I'll ask you both questions at once. What can we do, we as members of Congress, you as experts in your field, to inspire the next generation? As Dr. Barrow was talking about, other than movies like Hidden Figures, which I think is playing a big part right now in inspiring young people, what can we do as communities to inspire young people to keep this mission going?
Thank you. I think when you look across what NASA's doing, you can pick certainly specific observations. For example, in California, the work we've been doing with multiple sensors to look at, for example, with our GRACE spacecraft to assess the amount of water we've been pulling out of aquifers in California, to looking at, we've did a test project over the last couple years where we were working with farmers to develop an app to assess the amount of water, the health of their crops, the amount of water they were using, and it actually got some of the farmers to use about 25 to 35% less water on their crops. So there's a lot of specific examples of this, of NASA working to solve problems, whether it's in agriculture, in water management, where we again have an app that's now in the hands of water managers and farmers to help them assess crop health and control their water usage. So across the board, we've been taking NASA Earth science data, which has historically been for the scientific community to do science stuff with, and turning it into information that helps people in their everyday lives, whether, again, it's agriculture or water planning. This is critically important, and NASA has that unique global perspective, that unique vantage point of space. We develop the technology, we develop the next generation instrumentation, and when I say we, I very much mean with our university partners in basically every state in this country. It's the NASA family that's doing all this work and giving the benefits to people in every state in this country. For that second part, inspiration, Charlie used to say, Charlie Bolden, my boss, would always say, the best STEM outreach NASA ever does is when we launch a rocket into space. When we do great things, that's when we inspire. And believe me, I'm a huge fan of STEM education programs, especially in getting girls and underrepresented groups involved and engaged in STEM. But the best way we can do that, the best way we can engage that NASA generation is the same way that we did it at Apollo. When we have humans walking on Mars, you're going to see a huge spike in PhDs, just like we did after Apollo, the well-known Apollo effect. We do nothing better than when we do great things. And from The Martian to Hidden Figures, you see the public really engaged in going to Mars, and we need to accomplish that.
Thank you. My time has expired. I yield back. Thank you, Mr. Chairman.
Thank you, Ms. Bonamici. The gentleman from Alabama, Mr. Brooks, is recognized.
Thank you, Mr. Chairman. My question is to General Stafford, but please, if any of the other three would like to chime in after his remarks, feel free to do so. General Stafford, in your written testimony, you mentioned that during an 11-month period from 1968 to 1969, the Saturn V rocket flew 5 times, roughly once every 2 months. This launch frequency is obviously much higher than the early plans for the Space Launch System. Should we worry about the Space Launch System launch frequency, and how will this impact safety and cost?
Thank you, Mr. Brooks. When you have long delays in between, you still have to, it costs money to have the support people there to go. And the better tempo you hit, the cheaper it's going to be, or should I say, sir, the less cost it will be per launch. And also probably the safer it will be. And no, I think you need more than one every 2 years. And I don't know the optimum number, but you need it where you have a somewhat repetitive, rapid repeatability, and that would definitely enhance safety. It would reduce cost.
Well, you testified that you don't know the optimum rate. From that, I infer the exact optimum rate, but do you have some kind of judgment or range that you think would be preferable?
Well, Mr. Brooks, I would say probably a minimum of 2 a year. 3 a year would be desirable, but the minimum would be 2 a year, sir.
Would any of the other witnesses like to add any insight?
I would agree with that number. I think that 2 a year keeps the team active, keeps the team, on their toes, and that's what I think General Stafford is referring to, is that having a launch every 2 years or so is not, certainly not optimum, but 2 launches a year and a program that matches that, I think is compatible with what we talked about earlier.
Mr. Young?
Yeah, first off, your first question was, should we worry about it? And the answer is yes, absolutely. When I was director of Goddard, we managed the Delta rocket at the time. We launched 1 a month while I was there. When I was president of Marietta, we launched an awful lot of large Titan vehicles. I think there's one thing that everybody in the launch vehicle business knows. The higher the launch rate, the higher the probability of success. And when you talk about launching a sophisticated rocket once every 3 years or once every 2 years, I think the answer, in my view, is that's not acceptable. And so where does the cutoff come? I don't exactly know. If you get to what both comments that Tom and Jack made of 2 a year, 2 a year is not an unreasonable number. If you get much less than that, you really need to study the problem very hard to see if you have special techniques you can put in place to hopefully bridge the gap of not launching frequently. But the largest, I'm a big supporter of SLS, but the thing I would be most worried about is the infrequency of launches.
If I could also just quickly comment.
Please do.
The SLS rocket halves the time to get to the outer solar system. So for pursuing this question of going out to those ocean worlds of the outer solar system, the SLS is a great asset. So the scientific community is always ready to make use of those extra launches.
In the limited time I have left, this is a general question for whoever wishes to take a shot at it. Is there a market for heavy lift beyond NASA? Is it possible to design effective exploration architectures that make use of both the SLS as well as the commercial heavy lift vehicles currently under development, and what are the advantages or disadvantages?
Well, I'd take a crack at that. I think there is. About 10 years ago, published a book where I thought the private investors might be interested in funding both a heavy lift launch vehicle and activities on the moon in pursuit of lunar resources, particularly fusion fuel helium-3. Now, with the SLS, that partnership, I think, is even more viable with the government because the private sector can now, or the investor sector, can concentrate on the resource side of things rather than on the launch vehicle. So if you put together that kind of a partnership for lunar development, then I think, yes, there'll be a tremendous need for for launches on the order of 2 a year, if not more.
Thank you, Mr. Chairman. I see my time has expired. I yield back.
Thank you, Mr. Brooks. And the gentleman from California, Mr. Baer, is recognized.
Thank you, Mr. Chairman. I kind of think about, and reflect on my opening comments and think about the success of the Gemini and Apollo programs. Let me just read President Kennedy's quote. We choose to go to the moon. We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard, because that goal will serve to organize and measure the best of our energies and skills, because that challenge is one that we are willing to accept, one we are unwilling to postpone, and one which we intend to win, and the others too. And in laying down that challenge to us as a nation, he was also touching on the importance of strong science research programs, the importance of federal funding, the importance of investing in the next generation so that we would have that next generation of scientists. So now I wasn't born when he gave that speech, but I'm a direct beneficiary of the challenge that was laid out there, and I think all of us in the country are. Would you say part of the success was that there was a direct challenge in a specific timeline that wasn't about one administration to the next, because achieving the goal spanned administrations, but there was a clear goal that was set out? General Stafford.
That's a very good point, sir, and I do think we need specific goals and we need stability. But one thing I'd recommend to the committee, and I said this before, that I saw that was so effective was called the National Space Council. And it was put into law by the majority leader after Sputnik. At the same time, DARPA was formed and NASA was formed. That was by Majority Leader Lyndon Johnson. It's called the National Space Council. President Eisenhower decided not to activate it. For some reason, he thought it would take away some power. But as soon as President Kennedy was elected, he put Vice President Johnson in charge of the National Space Council. And believe me, sir, I was new to NASA then, but it flat moved, and then after him, Hubert Humphrey, and it continued on until President Nixon reorganized the White House in 1973, and it went away. The next time it was reactivated was when President Bush Sr. said, let's go back to the moon and on to Mars, and put Vice President Quayle in charge of the National Space Council. And that way it was focused, and you didn't have people like lower-level OMB people taking pieces out here or there, think that they help direct NASA, and it focuses it.
Absolutely. So having a specific goal, having a specific time frame that doesn't change from administration to administration.
That's right.
My colleague from Colorado gave me this sticker. It says, 2033, we can do this. Mm-hmm. And right, we can do this. And Mr. Young, you touched on it.
Yeah, if I could just add a little bit to your question. I think having it absolutely, the question is, answer is yes. I was a young engineer at that time, working for NASA. There was no confusion by me or my colleagues as to what our objective was, what we were trying to accomplish, and anything that was not critical to the success of that accomplishment, we just didn't do. In other words, we were focused on that goal and that objective. And I mean, I remember that as rigorously as I can remember anything. And unfortunately, that's not where we are today.
And I think if we want to accomplish what we want to accomplish, we have to get back to that. And, folks can sit here and say, well, we're in political turmoil as a nation. Look back at the 1960s. I don't think it was a time of political stability, yet we had national pride, we had a national goal, and we went out to accomplish it. And, in some ways, that could be what brings us together as a nation as well. Dr. Schmitt.
Congressman Barra, I totally agree with you. I think and that's why in my oral testimony and written testimony I indicated milestones. I think you need those, you need to commit to those. And one essential ingredient in that is Congress and the OMB and the White House have to be willing to provide management reserve of funding. You cannot make milestones in complicated programs unless you have a management reserve. Now, do you need 100% like we had in Apollo? No, we're much smarter than we were. But I think generally a 30% management reserve until you get to critical design review on various systems is absolutely essential to keep on schedule.
Great. And Dr. Stofan, you've already laid out what those milestones are to go into orbit around Mars in 2032. Was that the goal? Well, let's set that out there. Let's put it out there, and let's not continually change course. Let's actually dedicate the resources, the person power, and inspire that next generation. So I notice I'm out of time, but thank you guys for everything that you do for our country.
And thank you, Mr. Barra. And the gentleman from Illinois, Mr. Holgren, is recognized for his questions.
Thank you, Chairman. Thank you all so much for being here. You truly are our heroes. We're grateful for each one of you, what you've done and continue to do. So thank you so much for that. You're fine. But I have some questions for you, and this is an inspiring time, but also anytime I get a chance to talk about NASA is inspiring to me. And I think it's so important for us to be starting this new Congress and this great committee, which I'm so honored to serve on with Chairman Smith and my colleagues. But it is so important for us for so many reasons. But I think maybe one of the most important reasons is how NASA, throughout our history and continues to be such a place that inspires the next generation of astronauts, of scientists, of physicists, of people engaged in that discovery, that idea that has always been such a key part of who we are as a nation. And I have been really excited. One of the things that we've been doing in my district recently is we reached out, I represent 7 counties, but we reached out to high school students, and we've started a STEM Scholar program where I meet with 19 of our STEM scholars from around the 14th Congressional District in Illinois. We meet monthly going to different STEM facilities, whether it's a research facility or a university or other things, to be able to learn from them. Had a chance to be with some good friends of mine, the Kane brothers. Kane Tubular has worked very closely with NASA in exhaust systems for our rocket engines, and the students just loved it. We had a person from NASA come in and speak to them as well. So good for us to learn together, be inspired, but also to hear from them what's worked for them, what teacher inspired them, what program inspired them. So I asked them if they had any questions for NASA, for astronauts, for scientists who have been engaged in important work. And so I reached out to them, so I'm going to use the remainder of my couple of minutes to ask some of the questions that my STEM scholars had, if that's all right. First, Claire, who is just a brilliant young student. She has been involved in FIRST Robotics as an engineer, drive coach, and outreach coordinator for her team, Got Robot. But Claire asked, what has NASA done in the past, and what does it plan to do to continue to encourage students to pursue careers in STEM, to become that next generation of brilliant scientists and astronauts? And is there a way that NASA can help build curriculum or lessons that could reach more students to be able to do that? And I'd just open that out of what do you think NASA is doing or should do to inspire young people, that next generation of astronauts and scientists?
You know, through our NASA education programs, we have a lot of programs that are focused on kids in STEM and how to get kids engaged in STEM. And I think it's a constant challenge on how do we make sure those programs are really producing good results. You know, how can we make sure that they're effective? And I think over the last several years, we've really taken a hard look at our programs and tried to say, you know, where are we actually moving the needle on this? It's a huge source of frustration when we still don't see girls and underrepresented groups getting into STEM. One of the things we do that I think is effective is we partner with FIRST Robotics, for example, and I think it's a great program.
Me too. Good. I think, too, just continuing to tell your story, and we had the chance last Congress to be able to connect with astronauts up on the International Space Station, and I see all the time as I see the NASA channel, oftentimes our astronauts are connecting with students in school groups and how important that is. Let me ask another quick question. Andrew, another one of my STEM scholars from St. Charles, Illinois, another brilliant young man who is very interested in cyber issues, cybersecurity. He's a cyber patriot and also very active in the Civil Air Patrol and Air Force Association. But he had a 3-part question, if I can go through in my last one. As we continuously are moving forward in an interconnected world on the digital level with a greater need for computing power for our future space travel and advancements, we know that our adversaries will take advantage of every aspect of our nation's vulnerabilities. How can someone like me, this is Andrew asking, who is currently involved in cybersecurity education and competition for the past 3 years, contribute to the current and future space travel and advancement? Also, do you think cybersecurity plays a major role in NASA? Lastly, what is the current demand for cybersecurity jobs in NASA?
Well, it sounds like that young man is doing everything he needs to do to get ready.
I'm just trying to grab onto his coattails. He's
And
amazing.
to answer his own question, I have some responsibilities in orbital ATK for cyber security, and it is an extraordinarily complicated issue. It has to be addressed by the government as well as by corporations, and it's just going to be something that's with us continuously, and we're just going to have to start to get smarter and smarter. One of the things that has interested me recently is to try to get security built into processors. And the Draper Laboratory, with which I'm also associated, has developed some means to do that, so that you get away, you continue to use the firewalls and the whitelisting and other aspects of cybersecurity, but you build into the processor that kind of security. And I think it's an intriguing idea, and it's something that Andrew may want to look into.
Good, thank you. My time's expired. We have some other questions that I hope we can maybe give to you all. Some of my other STEM scholars had questions, so if we can follow up. One last word, Chairman. Just want to say thank you to General Stafford, all of you, so grateful for, but General Stafford, really appreciate all that you have done and mean to us, and really appreciated your words last night talking about Gene Cernan and your work with him. We miss him, but we're just so grateful to you and all that you mean to us as a nation, but also to our space program. But all of you, thank you so much. With that, I yield back.
Thank you, Mr. Holmgren. And the gentlewoman from Connecticut, Ms. Esty, is recognized for her question.
Thank you, Mr. Chairman. And again, many thanks to the ranking member, to the chairman, and really to our distinguished panelists today. We have a lot of STEM activities in my district and had the excitement of having a direct link from the International Space Station with 3,000 students watching from Waterbury, Connecticut, seeing a graduate from their high school talk to his former calculus teacher. And I will tell you, there is very little. You've all mentioned the importance of students really seeing that. So the challenge we face here is we've got a lot of different objectives for NASA on the table right now, and not enough money and not enough time to pursue them all in a sequence that inspires. So if you can talk a little bit more, how do we establish benchmarks? And if you are willing to say, what would you lop off or put down to lower priorities if we really think that manned exploration is vital, which many of you have said, if you have to triage, I think we'd rather plus up here, but we may not have that option. And I see Mr. Young is ready to go with the triage question. Thank you.
It's a great question, and I actually think the crucial question. My personal belief is that the priority for human spaceflight should be exploration. Boots on the ground at either Moon or Mars. My choice is Mars. To do that, we've got, as you say, we've got to not do some other important things. My personal belief is, as I mentioned, is commercializing low Earth orbit. I think NASA should not be in that business except for providing technological support. So that would be my item that I would cross off. International Space Station is the more difficult of the questions. I personally, and there's no way that we can have a credible exploration program and a credible low Earth orbit space station program at the current budget, in my view. So I would prioritize those things that are necessary to support humans to Mars. I would accomplish those, and I would transition, if possible, it to the commercial world as soon as I could. The other thing that's going to consume a lot of resources is the decade worth of effort in cislunar space. I personally believe there's a lot of things that need to be done in cislunar space to support the Mars program, but I wouldn't establish a cislunar space program on its own. I would establish a Mars program, and then from the Mars program, I would figure out what do I need to do in cislunar space to get to Mars. So I think a human to Mars mission will stretch us almost to our limits, but I think is achievable. But to do it, we've kind of got to do just what you said. We've got to prioritize. That would be my personal priority. The country could decide it's another priority. Maybe commercializing in low Earth orbit is the right priority. If that's true, get the rest of the stuff out of the way. But it's not what I would personally do.
I see at least two other nodding heads on prioritizing Mars. Does everyone have an agreement around that? Because we are going to have to make some very difficult decisions if we are going to achieve any of these things in a time frame that makes any sense. And I think we, as our colleague Dr. Barra underscored, you do need focus. And that does help. Public support is enhanced when there are timelines and there are benchmarks and people can see that progress. That galvanizes support, which makes it easier for us to achieve not just that goal, but other ones as well. Others who like to chime in?
I think Tom Young has articulated very well. I've already made the leap that the moon is extraordinarily important to get to Mars, but I think anything you do in this so-called cislunar space has to be with that in mind. It doesn't mean other things won't happen as a result, scientifically and operationally, but you really do need that experience. A generation or two needs the experience that we used to have as a result of Apollo if you're going to go to Mars successfully.
Yeah, I think it's really critical that we do stay focused, and I would call the committee's attention to the work that Mr. Lightfoot has been doing over the last several years to really look inside NASA and say, you know, what are we duplicating at our various NASA centers? How do we focus? Over the last, I would argue, at least 10 years, NASA has been carrying too many potential futures, too many potential paths. Robert has already begun the work to try to say, we have one path. We're going to Mars. Let's narrow this down. We've started on that path. The guidance of this committee, of this Congress, would help solidify that.
Thank you. That's all very helpful for us because, again, we want to be helpful in achieving these missions. And if there are too many missions, none will be achieved. And that is a great loss, not to just this country, but really to the future of the human species. So we would like to be helpful in this process. Thank you very much. And it looks like the
Yes, I'd
General
like to
also
point
has.
out one thing to the committee, and particularly the new members. In physics, when we talk about Mars, you know, it's in a 687-day orbit where we're in a 365.25. It's inclined 1.9 degrees. Put all this together. JPL did this for us in a study. And you can only launch for Mars every 26 months. And you have about a 60-day window. But also there's a sinusoid of energy per kilogram or pound, if you want to put it that way, that's required. And we're right down, there's a 15-year sinusoid. And we're right down near the minimum now, 2016, 17, 18. Then it starts back up. By the time you get to, say, 2024, 25, you're up near the peak, so it's going to take out. You can only put a little payload there. Then it starts down. And so 15 years from now, 2031, 32, 33, you're down in this thing. So you can set a target. But that is that one thing when you talk Mars that you have to remember all the way, that 15-year sinusoid.
I'm going to beat that with fusion propulsion, Tom. You won't have to launch every 26 months.
Thank you, Ms. Esty. And gentleman from Oklahoma, Mr. Bridenstine, is recognized.
Thank you, Mr. Chairman. Serving on this committee is a high privilege, especially because we have the opportunity to discuss things like this with this amazing panel. So thank you all for being here. Before I get started on Moon, Mars, I think that's an important discussion, but I want to say the first time I had a conversation with Lieutenant General Stafford, I was running the Tulsa Air and Space Museum. I had just left the United States Navy as a pilot, and here I am at this museum. We made an effort, Mr. Chairman, to get a space shuttle in the city of Tulsa. And we had a long history with the shuttle. We built the bay doors on the space shuttle. We had built the shuttle carrier aircraft, the 747 that carries the shuttle on its back, was modified in Tulsa. We built the big devices that pick the shuttle up and make it vertical for the launch stack. NASA said you needed a 10,000-foot runway to have a shuttle on display at your museum. You need a museum dedicated to education. So we made this effort to go after a shuttle. And I was pretty new at the museum at the time, and I get this call, and my staffer comes in and says, General Tom Stafford is on the phone for you. And I said, yeah, and the Easter Bunny's online too, right? And of course, General Tom Stafford was on the board of directors for the National Museum of the U.S. Air Force. And he wanted to let me know that the U.S. Air Force Museum was going to be getting a shuttle and not the Tulsa Air and Space Museum. I'm sad to report, sir, that neither one of us got a space shuttle, but it was a great conversation, and I appreciate you being from Oklahoma. If none of you if you've ever been to Oklahoma, if you ever get a chance to go to Oklahoma, I highly recommend visiting the Tom Stafford Museum. You're doing a lot to inspire the young generation in Oklahoma, and thank you for all your great work there. I want to talk for a second about this Moon Mars thing because I think it's important. While we all want to go to the moon, and certainly with my friend from Colorado, Mr. Perlmutter, 2033, great goal. I think it ought to be 2032. I think most Republicans agree with the 2032 number. But while that's important, there's also, and I've heard Dr. Schmitt and Lieutenant General Stafford talk about the geopolitical issues here, the fact that there is a soft power element here. We know what China is doing. They're launching taikonauts on Chinese rockets to their own Chinese space station. Not too long ago, they put an orbiter around the moon to map the moon. After a year of mapping the moon, they launched it deeper into space to the L2 point, 60,000 kilometers on the backside of the moon, where it shut down and just hovered for a period of 8 months before repowering and flying into deep space in formation with an asteroid. That is a massive achievement, an accomplishment that is astonishing. We also know that the Chinese have launched direct ascent anti-satellite weapons, one that in fact shot down one of their own satellites, creating a space debris field of 3,000 pieces. We also know that they are currently testing anti-satellite weapons all the way out to geostationary orbit, where our most important communication satellites, AEHF for nuclear command and control communications, WGS for those of us that are tactical operators, we depend on WGS, and of course all of our space-based infrared systems to detect missile launches, all in that very important orbital regime out there in geostationary orbit. The Chinese have demonstrated, if not the desire, they have at least demonstrated the capacity to attack that geostationary orbit from above. And that is a critical concern that everybody on this committee should be taking note of because of the situational awareness limitations that we have in deep space. So when we think about the moon and when we think about Mars, we all want to get to Mars in 2033. I think that's a great objective. I will also say that cislunar is critically important for the geopolitical position of the United States of America. And the Mars is the horizon goal. It's critical. We need to get there. The moon, I believe, is necessary. And Dr. Schmitt, I'm going to turn it over to you for a second because you've talked about how it's possible that the U.S. government could, in essence, provide transportation to not only lunar orbit but to the lunar surface, and have the private sector invest in developing not only the moon but the capacity for cislunar, which is a geopolitical concern right now for the United States. Can you address how we could leverage commercial in that realm?
Well, I've been convinced for a long time, Congressman, that ultimately the private sector can truly commercial, as Tom has pointed out, truly commercial, for-profit, exploit the resources of the lunar surface. The part of the lunar surface called the regolith, which is a debris layer that covers the moon that's several meters thick, that contains hydrogen, oxygen, nitrogen, carbon, and helium, and particularly this fusion fuel called helium-3. So the only basis I'm aware of for a truly commercial operation is in lunar resources, and both for use in space and for use here on Earth. And if the government is, as it is right now, is moving towards developing heavy lift launch vehicles, then that opens the door, I think, for this partnership to really be a viable one. And I talk to people about it all the time, obviously, and we'll just have to wait and see whether the investor community or the energy community step up and realize that this long-term potential is there.
Thank you. I yield back.
Thank you, Mr. Bridenstine. And the gentleman from Virginia, Mr. Byer, is recognized for his
Thank you, Mr. Chairman. And Chairman, thank you for having this hearing, which is fascinating. Thank all of you for being here. Dr. Stofan, when Mr. Young, in his testimony, let me quote, he said that basically the next flagship science mission will be the James Webb Space Telescope, initiated in the Bush administration, with nothing comparable initiated during the 8 years of the Obama administration, and goes on to suggest a lack of leadership during these last 8 years. You were there as the chief scientist. How would you react to that?
Well, obviously, I don't agree with that. We initiated the Mars 2020 mission. We'll be setting the stage to return samples from Mars in the mid-2020s, which I didn't even get into. It's critical to bring those samples back in the 2020s, which will allow us to develop our entry, descent, landing, ascent, and return to Earth capabilities. So Mars 2020, W first, our next telescope after James Webb was initiated under this administration, a mission to Europa initiated under this administration, this past administration. A revolution in small satellite technology that's underpinning the huge revolution. We just saw all these Planet satellites launched a few days ago. All that technology has been worked on at NASA over the 8 years. It's transformed through a lot of our programs, our small satellite, our lower cost options in astrophysics, heliophysics, planetary Earth science. We've made incredible progress over the 8 years, building on the long bipartisan history of NASA. And so I don't think it's, oh, we accomplished a lot in the past, we've done nothing over the 8 years. I think NASA has continued to execute the decadal surveys. We've made strong progress. We will hopefully continue to make strong progress with this committee's support.
Thank you. Dr. Stafford, one of the conversations that we have in this committee is the role of earth sciences in the NASA's budget. But as I understand now, where it's about $1.9 billion out of the $19.5 billion. And I know the chairman, my friend, has talked about the rebalancing of the NASA portfolio. And so we often are concerned that this means the disappearance of the earth sciences budget as part of that, redirecting to deep space, for example. What would happen if NASA's earth science budget were eliminated?
Well, first of all, I would point out that the earth science budget has actually been fairly flat over about the last 20 plus years. In fact, if you look back at around 2000, it was about $1.4 billion, which if you put that in today's dollars, we are actually lower. So the earth science budget has actually not grown. It's slightly shrunk. Again, NASA has the unique vantage point of space. We build NOAA's weather satellites, the GOES-R, which has been returning amazing images of this planet. That satellite was built by NASA. We do that for other agencies. We build Landsat, which is critical to farmers, to urban planners all around the world. We are studying the global water cycle. We're developing that next generation of instruments. NASA's Earth Science program is critically important, and I would also remind people that the technologies that come out of the investments in the Earth Science program spawn new industries, that downstream application of earth science data collected by NASA and made open to the public have created new companies, Orbital Insights, Digital Globe. I can sit here and name companies that get downstream value, create jobs all across this country. The Earth Science program is an investment in this country, and it returns benefits to all of us every day. Thank you.
And my friend, the chairman, doesn't want me to exaggerate the complete elimination, but rather rebalancing. Okay. Dr. Schmitt, wonderful to have the geologists here. I know you're deeply involved in fusion power too, and talked about fusion power for this. In your work, do you see any relevance for fusion power for power here on Earth?
Well, I certainly do. I think having done an economic analysis of this some years ago, I think the potential for helium-3 fusion power on Earth is very, very great. Now, it's not something that's going to happen overnight, and it takes a long view of things before you start to make a profit on it. But nevertheless, the resources there on the moon, the technology is advancing here on Earth to use helium-3 in fusion devices. Most of that has been done with private funding so far. You may have recently seen a press release from Tri-Alpha, a Paul Allen funded operation, where they are working on boron, what's called p-boron 11, but the technology base is equally compatible for lunar helium-3 fusion power. The nice thing about helium-3 fusion power is that you don't produce neutrons. Neutrons are bad actors. They create the radioactive waste that we worry about. And certainly a tritium, deuterium fusion device is going to create a great deal of waste, and that's often not talked about when we think about these the ITER project in Europe and so forth. But helium-3 produces protons, which can be directly converted to electricity at high efficiency, as well as without the difficulty of waste production. So I think in the long term, if you want an relatively environmentally benign energy source for the very long term, then this is something that ultimately I think we're going to look very closely at.
Great, great. Thank you very much. Mr. Chair, I yield back.
Thank you, Mr. Byer. The gentleman from Texas, Mr. Weber, is recognized.
Thank you, Mr. Chairman. Dr. Schmitt, I think it was you early on in your comments who said that you think one piece of advice you would give NASA was to resist political diversity for the agency. Would you elaborate on that?
It's just that the kind of things that we've talked about in terms of focusing, many of the things that NASA does are really within the purview of other agencies, and I think that that ought to be examined very closely by this committee, which has responsibility for several agencies, not just NASA. And that just because you start to focus on Moon, Mars, and deep space doesn't mean that these other programs have to go away. They can be, I think, taken under the umbrella of other agencies, and that ought to be looked at very carefully. Now, does NASA stay in the business of actually providing technological assistance, such as they do for NOAA? That's a question that you'll just have to discuss and try to answer. But other agencies do have the same the responsibilities in the areas where NASA has been diversifying over the last several decades.
Okay, that was a little bit of the conversation I think that the ranking member chair just alluded to, that, you know, that it seems like there would be a rebalancing of the budget, and perhaps that's part of what you're talking about taking on in the budget process. I cannot overstate what I believe is the importance of NASA. And General Stafford, I don't want to get into your bailiwick, but not having had the privilege of serving in the military, but you know, they say that whatever force occupies the high ground has the upper hand, and folks, there is no higher ground than space. And to my good friend from Oklahoma, Congressman Bridenstine's comments about the Chinese able to shoot down satellites, that ought to be pretty alarming and a wake-up call for us all. You actually said in an exchange with Suzanne Bonamici earlier, or the comments were that she didn't want space exploration to become an issue between the United States and Russia. Well, that was before Jim had made his comments about China. Do you think that's a prudent outlook, to not be on guard and to really want that competitive edge and that military edge? Do you think the United States literally ought to be going after that kind of edge?
Well, Congressman, to me, the United States, in this case, it would be I would think the Air Force responsibility. Could be part of it, could be Army under ballistic missile defense, but we need to be the leaders in the world. And we need to have, under the DOD, funds for that.
So you would say that leaders in the world because of not just because of STEM and other, the pride that Dr. Amibera talked about, but other issues, but for national security.
Right, for national security, absolutely. What Mr. Bridenstine, Congressman Bridenstine has mentioned there, that we need to be right there out in front of everything, on top of everything.
Congressman, if I may just add to those remarks, we tend to forget that Apollo was a creature of the Cold War. It really was.
Oh, I don't forget.
And we gained a great deal of science, a great deal of technology, many other things from that effort. But the stimulus, the impetus, was the Cold War, and a very important part of it.
Right.
I would say so. That has to be kept in mind, and as far as I'm concerned, with Congressman Brendan's comments, we are very close to being in a Cold War today, and need that kind of impetus, and with a milestone focus, as was discussed earlier.
Well, thank you for saying that, and the gentlelady from Oregon's not here, but I think one of the comments she made was that she didn't want to see this become an issue between the United States and Russia. But I think when you're dealing with the Russians giving us a ride to the space station, which to me is an absolute travesty, I think we have to differentiate between the Russian space agency, and you all would know that better than I would, and the Russian military. But I would tell you, not knowing any more about that differentiation or either of those agencies than I know, I would have to believe that either one of they would sell us down the river in a heartbeat if it was to their advantage militarily. Would you all agree with that?
I would.
Well, we have to to look at in certain ways, the arrangements with Russia is like a stovepipe. We deal with the Russian Space Agency, but they have lots of other responsibilities besides what we call, quote, civil space. And they have lived up to their agreements on that, but they have other agreements too. They have other things that they support.
Okay.
Where NASA is primarily all civil. And had we continued on the Constellation program, we'd have had American astronauts flying on American rockets and spacecraft in late 2013 or early 14.
Just in
Right.
time.
Well, thank you for saying that, Mr. Chairman. I yield back.
Thank you, Mr. Weber, and the gentleman from Colorado, Mr. Perlmutter, is recognized.
Thank you, Mr. Chair. First, I'll start with this. We start them young in Colorado. Got the outfit at the Air and Space Museum. Finn Henderson, 4 months old.
Ah, any relation?
Yeah, grandson.
Grandson.
2033. And so, General, I want to talk to you about this and to the entire panel. And I thank you all very much for your testimony today and for your service. And Senator, I'm going to get to you because we're going to talk about budgets for a second. But you mentioned sort of the orbital mechanics of all of this. And we had a panel about this time last year of some NASA agency execs. And I expressed to them my disappointment that we hadn't gotten to Mars by now. You know, Star Trek, Star Wars, on the moon 40 years ago plus. And why aren't we there? And they said, well, because of fits and starts between administrations and Congresses. And I said, if you had the revenue, if you had the support, steady, sufficient revenues, what's the earliest we could get to Mars? And I was hoping they'd say 2024, and then they kind of went through the 2-year cycles that you just talked about, and they said 2033. If they had steady, sufficient support. But that's the $64 question, because it's been kind of fits and starts for all of you, and I, as a legislator, apologize for that because we haven't given you the steady support. And to your point, Mr. Young, you know, it's a mixture of things, the agency's expertise, the private sector's ability to really bring forces, and potentially the international community as well. So it's a responsibility. I mean, we find more common ground on this committee than any of the other committees I've served on in this Congress. And this area especially, space exploration, is the place where I think we really do all have a common interest and want to see us move forward. And it might be a different thing for each of us, what floats our boat, whether it's a national security question or a science and pride question, but whatever it is, maybe we are at the confluence of something big here. And the reason I'm looking at you, Senator, is the revenues are a hard thing, but they're not impossible. We came up with $800 billion over a weekend to save the banks in 2008. It was a Republican administration and a Democratic Congress. If we can't, and the number that was given to us was about $200 billion, maybe $250, over 17 years to get to Mars. And, you know, different kinds of ways to do it. I'm a lawyer. I'm not going to say other than I'd like to see this result and let you scientists and engineers tell us how to put the pieces in place. So I just like your reaction to that.
I think you've hit on a very important point, and that rather than thinking in terms of what is the total cost, you need to think in terms of what is a reasonable annual cost of going forward. I think that's what happened to the initiative in the Bush 41, is that it got tarred with the total cost. When you can't operate that way, you've got to operate on an annual basis, as you've indicated, and we need to decide what is that, what is a reasonable number in order to make the milestones. Now, I think 2033 is probably doable. I did not have it in my list of milestones, primarily because I'm still not sure that we're going to give NASA the management tools to make that happen.
Well, and
this is not the NASA that was managing things when Tom and I were flying in Apollo.
so let me talk to you about that. Let's say, you know, and you know from being a legislator and the diversity of interests around this place, how difficult it may be for all of us to come together to have a 17-year plan. Sometimes we can't plan 17 minutes, you know. But if we're able to do that, I'm assuming, and I look to you, Mr. Young, and to you, Dr. Stofan, in general to you for your comment, can NASA, together with its private sector contractors, find the management tools to do it? Or is that an impossibility?
You know, I've spent the last 3 years visiting every NASA center around this country, talking with our private space contractors. The people at NASA are totally capable of doing this. They are chomping at the bit. They need clear direction, they need focus, and they need budgetary support. The people are there, the expertise is there, they're waiting, and they're eager to get started on this.
Yeah, I think Ellen said it very well. I agree with that. I mean, I think that it clearly can be done, but it takes some bold leadership, you know, to make it happen. I must share with you, you're talking about dates, and, you know, Jack was, and, you know, some of these dates are mind-boggling to me. You know, we were talking about earlier Kennedy's thing. I think from Kennedy's statement to humans on the moon was 8 years. That I remember the first large space project I worked on as a very junior engineer was the original lunar orbiter, where we took the photographs that found the landing sites for Jack and.
Wonderful program, Tom.
Yeah. That program from start until we were in orbit about the moon was 27 months. And by the way, we were criticized because the commitment was 24 months. But so we obviously have allowed, which I think is what Jack was trying to say, we've allowed an enormous amount of non-value-added work to creep into our execution of programs. And, you know, that's something that, you know, that we should try to eliminate the max we can. But I think Ellen said it well. I think the people who will do this job are chomping at the bit for the leaders to just unbridle them and let them go.
Thank you. General?
Well, the one word that sticks in my mind, Congressman, is that this committee was really epitome of back in 2010 is the word courage. And this committee and its corresponding committee in the other body went forth their courage right in front of what the administration did in cancel Constellation and started the SLS in Orion. But when you said, why weren't we there in 2016? Well, when we did this study for President Bush 41 and Vice President Quayle at this joint press conference, our target for Mars was 2016, sir. 2016.
Well, we gotta get on our horse here and get it done for you. Thank you.
And one thing about it, again, when I recommend the National Space Council, so you have somebody with horsepower at the top. Doesn't take any big bureaucracy. 4 or 5 people is all you need in the National Space Council. And take that and drive it so you don't have those detractions.
Thank you.
Thank you, Mr. Perlmutter. The gentleman from California, Mr. Knight, is recognized.
Thank you, Mr. Chair. I'm going to talk about a completely different subject. I know everyone wants to talk about Mars and the moon, and that's great, and they're laudable goals. But you can't get to space until you go through the big A. So I will be talking about the big A. Aeronautics is now about $700 million. I noticed in Dr. Stofan's comments, I read through them, and I appreciate her bringing up the X-plane program and bringing up all of the things that we can do. General Stafford, I will go with you first. We now have a new Aviation Horizons effort where we have many X-plane programs that are coming online. The X-57 is the new designation, but the big one that I'd like to talk about is the low-boom supersonic demonstrator, because we've been flying across this country at 0.8 Mach for as long as we have flown across this country. And I would hate for my children, who are now in their early 20s, to be my age someday and say, hey, we're still flying across this country at 0.8 Mach. And I think that that would be one of the great achievements that we could do, that NASA could do, to prove this, to lower the supersonic boom down to the 65 decibel or lower so that we could remove this archaic 1973 FAA law and really do something. So we could travel across this country at 1.8, 1.9. And think of what the economic boom that would be, that people could get to their destination 2 hours quicker that are going across the country. So just your opinion of that, General.
Well, Congressman Knight, I think you've made a very valid point, in particular not only across the country, but across the ocean.
Sure.
And I've been fortunate to fly the Concorde many times, and so I think you're right on. I'd like to remind the committee that Congressman Knight's father was a classmate of mine in the test pilots, Air Force test pilot school, and he flew the X-15, and he set a couple of world records that still stand, so we're very proud of your father, Colonel Pete Knight. But your X program, I think, is very valid, sir.
Thank you. And Dr. Stofan, if you have any comments on that?
I think NASA's aeronautics program, as I said in my submitted remarks, is really critical. Obviously, the aviation industry is a hundreds of billions of dollar industry here in the United States, and the fundamental research that NASA does, from looking at all the technologies that we help to develop that are in the latest Boeing aircraft, we really underpin a lot of the developments in the U.S. aviation industry. And so from the low boom demonstrator to the X-plane program, the investments that NASA makes in aeronautics are really critical, and I think they should be supported by this committee going forward. I would point out we're also doing work in green fuels, which is critical because when you fly planes at supersonic altitudes, you're putting greenhouse gases into a place in the atmosphere where they reside for a long time. So NASA also is doing a clean fuels program along with the low boom demonstrator. Both of those are critical for allowing supersonic air transport.
Absolutely, and I wanted to bring up just another point. I know that that Mars and the Moon are the big goals. They are, and I think that the way we get to those big goals, and I think Dr. Schmitt said it, that you've got to lay out the goal, and you've got to say that we are going to do this by 2032, or we are going to set this, and we've got to fund it every year. That is Congress's mission, is to fund it every year. The smart people will figure it out. NASA is way ahead, and I know that they can accomplish these goals. But if we don't fund it every year, and if we don't have a mission through administrations, we will not get there. It will be a start and stop, just like we have done with many different programs. And I bring up hypersonics that we have worked on for the last 50 years in start and stop issues. Our last start and stop was the X-43 and the X-51, and we have done great data collecting over those periods of time. But now we are seeing other countries take our data, steal it, and then jump forward, and then maybe fund. So now we are seeing other countries maybe establish a weapon that would hurt us at 3,800 miles an hour. And so those are the things that NASA is also got to be very cognizant of when we do these budgets, is that the big items are the big items, but there are also many, many items that accomplish missions. And my time is...
Congressman, if I could.
Yes, sir.
I have suggested, and I think that the implication of your remarks is that aeronautics is terribly underemphasized. And one way in which you might assist the refocusing of NASA is to recreate the equivalent of the old National Advisory Committee on Aeronautics, NACA.
I firmly agree.
And let it stand on its own, and I think it can stand on its own. From Apollo on, NACA programs contributed a tremendous amount to Apollo, but then aeronautics research in general began to decline under those pressures. And I'd like to see a whole new emphasis in aeronautics, and I think you can do it with with recreating an agency that has that focus. I like focused agencies, I really do.
Congressman Knight, the one thing too that they need to do is coordinate with the Air Force Research Lab. I think this is a great way for cooperation. And there's no doubt you brought it right out that I've been briefed on some things the Chinese have done, And they've really advanced in hypersonics and weapons, not nuclear, but just with chemicals, or you put just energy, V squared over 2G, it's got a real tremendous effect. But you're right on that. We need to get back into hypersonics.
Thank you, sir. Thank you, Mr. Chairman. I yield
Thank you.
back.
Thank you, Mr. Knight. And the gentleman from Texas, Mr. Babbins, recognized.
Yes, sir, Mr. Chairman. Thank you very much. Just been a real treat to hear you experts give great testimony, and a lot of great questions have been asked and had some very enlightening answers. I have several questions that I wanted to ask, but I think we've already touched on them. But there's several questions that I feel like I'd like to ask about an announcement that was made yesterday. Acting Administrator Robert Lightfoot of NASA announced that he was directing Bill Gerstenmaier to conduct a feasibility study to determine whether the first exploration mission, EM-1, using SLS and Orion could be flown with a crew. It's currently planned as an uncrewed test flight, as you know. Well, we welcome that news of this study, but some of the questions that this may elicit, I would like to hear some of your opinions. The first one is it possible to technically justify it? Can the additional risks be justified and addressed? Should there be an off-ramp if the schedule slips too far or cost comes in too high? Is there an alternative scenario that accelerates flying astronauts, that accelerates exploration by moving EM-2 forward as well? So I would like to ask each of you, and we'll start with you, Dr. Schmitt, is it possible to technically justify this?
I have no idea. I think we're going to have to, both outside and inside of NASA, they're going to have to look at it very closely, whether you can man-rate the system that fast and meet the kind of criteria that Tom has put forward on many occasions that meet the safety that's a requirement. The one thing that will always hurt a space program is an accident, and there's always risk. You have to be willing to take those risks. But still, you also have to make sure that you fully understand the risks that you're taking, and that I think we'll just have to wait and see whether and it also depends on what the administration decides it wants to do. The next NASA administrator will certainly be responsible for doing whatever that turns out to be.
Right. Okay. Thank you. Yeah, General Stafford.
Right, Mr. Babbitt. The space shuttle. We flew that crew on the first flight, and it flew. And I was involved with that decision because at that time, it was done a few years before that, when I was head of the astronaut group with Deke Slayton. We did not have faith in the autopilots, and so we knew that the crew was there. And I think what we'll have on the SLS, we're using parts that's been there before. The main core has 4 space shuttle main engines, and they've been liquid engines, and they've proved out over a period of time. The solid rocket boosters are elements of the space shuttle, only we're 5-segment now instead of 4. The upper stage, they would have 4 RL-10s, and those have been around for 50 years, improving all the time, and the last I saw, sir, there's been 480 straight flights. So the power plants are in pretty good shape, I think. So its main thing is building that core, and I would feel better about flying this than we did other things.
Thank you for that. Dr. Stofan.
You know, obviously the approach Robert's taking by having Bill Gerstenmaier do a study, I think, is the correct one, and NASA will, whether it's commercial crew or whether it's the SLS Orion flight, will always put safety first. Would I personally love to see the schedule accelerated? Yes, I would love that. The sooner we get to Mars, the better. I think a bigger issue is one that we touched on earlier, is that flight rate of SLS and Orion going forward after that first flight, which I think is still an ongoing concern.
Yes, okay. Mr. Young.
Yeah, just to add my comments, I think doing the study is good. So I applaud that. A little bit of what Ellen just said, you know, I would add actually a part B to it, and that is, God, it's a long time between the first flight and the second flight. today, the plan, with the first one being uncrewed and the second one some few years later, which I don't remember the exact number of years, but some years later with a crewed. And so part B, in my mind, if you're really going to take a hard look at this overall plan, is how can you accelerate it so that you do the first one and then within a few months after it, you do the second one. Somebody commented earlier about the number of flights of the Saturn V within a year.
Right.
So I think that whether the first one ends up being crewed or uncrewed as the current plan is, the second one being as soon after it as is practical, meaning a few months, which is probably a budget issue, but would be a responsible thing to consider.
Thank you very much. And, Mr. Chairman, I yield back. Oh,
Mr.
somebody have
Chairman,
something
just-
else? Yes, sir.
Just quickly, a little history. The first full-up use of the Saturn V with a crew was the Apollo-8 mission around the moon. So you're saying, can we do that now with the SLS? The same kind of thing.
Same answer that.
And the Apollo-8 mission, of course, was sort of an afterthought when we were running behind schedule on the lunar module. And they actually had problems with the Saturn V on one of the uncrewed launches. And that had to be the pogo problem in that case. And they even had some of that problem on the Apollo-8 launch. So you have to make sure that you really understand your launch systems and that the full-up system is what's important. And that was Dale Meyer's orders to von Braun is let's launch this thing full up, finally, because von Braun would have tested it to death. I think even he admitted that later.
Okay, thank you, Mr. Babin.
Thank you, Mr. Chairman. Thank you.
The gentleman from Louisiana, Mr. Higgins, recognized.
Dr. Schmitt, in your long list of accomplishments, your bio, you've helped to uncover much of the geological history of the moon and its relationship to the early history of the Earth, further definition of the violent impact history of the Earth during the period when life began, the potential role of the largest impact basin in the evolution of the moon, identification of samples of the lunar mantle, the definition of the sequence of formation of 3 large lunar basins. The list goes on, but it does not mention that you were certainly the only pilot in history that almost landed a lunar module on an aircraft carrier.
Well, thank goodness the Navy moved the carrier because our guidance system was so good we were about to hit the carrier.
You were on target. I bring that up. That aircraft carrier was the USS Ticonderoga. My father was a Navy pilot in World War II and had the honor of serving on that aircraft carrier. My father was a fiercely patriotic man and did not trust the Chinese or the Russians. Perhaps by the nature of my DNA, but certainly through the course of my life and in view of recent events politically and space-based, neither do I. So my question to you, sir, is regarding America's interest in maintaining a persistent human presence in space, be that a human presence on the frontier and a low Earth orbit, geostationary, or an American human presence based on the moon, is it necessary that we involve international partners as we push the frontiers of the American space program?
I personally do not think it's necessary. I think it takes the United States to be the leader of the program as it was in Apollo. We had international partners to some degree in Apollo. We certainly had a lot of international participation by some of the engineers, and the lunar sample analysis program was an international program. So yes, but it takes, I think, our leadership. I think we need to be in charge in order to provide an opportunity for international partnerships. But no partnership, I think, should be in the critical path. If you're going to go to Mars by way of the moon, that critical path has to be our responsibility. You can't be waiting for some other partner to deliver and to and again, I think it's just absolutely essential that there be a leader of these kind of programs.
I concur and thank you, General.
Yes, sir. I'll echo what Dr. Schmitt said. America needs to be a leader. If you're going to be first in the world, you need to be first in space. And we have to be a leader. And I've been deeply involved with the International Space Station, the partners. I've been deeply involved earlier with the Soviets and now the Russians. And to me, you have to completely differentiate the Soviets from the Chinese. It's a whole different world. And I've been to Russia maybe 35 times. In fact, I adopted 2 Russian orphan boys. So I think I understand a lot of the Russians and what it is today. It takes too long to go into it in this committee, but the Chinese are a complete different type of effort. And so I agree with your father on the Chinese completely. And in the Russians, it's really one more of a nationalistic, and it's now materialistic too. But it's a different world. And it takes too long to go into it here.
That's a unique and valuable perspective. I would encourage my colleagues and a member of this committee to maintain a sharp focus on our national security as we move forward with our plans to advance the causes of NASA. And I certainly agree with this panel that has appeared before us that we need to be completely focused with the mission parameters as laid out over the next 15 or 17 years. Seems to be the window. And I look forward to working with my committee members and colleagues on both sides of the aisle and make it happen. Mr. Chairman, I yield back.
Thank you, Mr. Higgins. And the gentleman from Florida, Mr. Posey, recognized for his questions.
Thank you, Mr. Chairman. Thank you for calling this hearing, Mr. Chairman, and thank the witnesses for coming here. It's been probably 5 decades that I've respected and admired you and your accomplishments. The words that come out of your mouth are like gospel to me, and I just can't thank you enough for your attendance here. I was in high school when Kennedy gave his famous speech about why go to the moon, and that became my first priority in life, was to have my fingerprints on that rocket that took our men to the moon and returned them safely. And General, I appreciate you pointing out the third stage reference a little while ago, and that was my stage, and forever be proud of that. A little bit of a lump. You know, poll after poll, study after study, survey after survey shows the general public thinks we spend 20 to 25% of our budget on space, and we all know it's more like 1/2 of 1%. And they don't understand the benefits. They don't understand the importance of our national security, the ultimate military high ground, the economic, the STEM, as you so well pointed out, the benefits of it. And so, you know, we're trying to change that. And we're trying to, you know, make sure or ensure that NASA considers everything that they do as a stepping stone to go on to Mars. You know, we think that's got to be the priority. When everything is a priority, nothing is a priority, and that's where we are now. So, you know, kind of playing whack-a-mole. I usually carry around a chart that has like over 24 missions to nowhere, started by one Congress or one administration, canceled by another. And you mentioned, General, a little while ago, we'd probably be on Mars now if we stayed the course last time. That's really a big problem that we have. The selling our colleagues on the importance of space is not an easy job either. The people in this committee all respect space and are enthusiastic about space. And you ask anybody on my staff, what do you do in Congress? Well, the first thing we do is we sell space every day in every way. You know, it's important. And you all remember when the space station survived by just one vote in Congress. You know, so we keep a running list, a House Action Team, a hit list. You know, who's with us, who's against us, who says they're with us, who's not, and we try and keep this in perspective. But you know, we've seen a NASA budget take hits for a big city cops police plan. We've seen another department take money out of NASA to do a responsibility they're already tasked with and they're already funded for. You know, the NASA budget's kind of been like a big piñata. Occasionally, and we want to see that doesn't continue. But we have to sometimes consider that maybe NASA is not our biggest assistant in this. And I want to share with you one time, you know, the beautiful educational and impressive press kits that we did for each shuttle launch, that anybody came to one of those, there's the decal and the stories and the stickers and the pins, and I mean, very impressive. You see, if you went to launches, you see people clutching these valuable things. And so when they did the last shuttle launch, I contacted my local NASA PR people and said, look, I'd like to get 434 press kits, and I'd like to make it a priority next year to deliver one to every member of Congress and talk about how this will be a treasure for their grandchildren, and there won't be any more of it, and give me the opportunity to discuss one-on-one and have something in hand, because members' times are valuable. Well, my local PR people went to work to get that for me, but NASA Washington said no. They said, that's not your job. So, you know who did it? Nobody did it. And it's a great opportunity lost. So, with the time remaining, I'd kind of like your thoughts on promotion, where you think we could do more, where we could be more persuasive with NASA.
Well, you're my congressman now, since I live in Satellite Beach.
Well, you and Buzz both. Well, thank you. Don't hesitate to call on me, General.
Right, but what I've observed over the years, and Jack, I'd like your opinion too, one of the weaknesses of NASA has been its public relations.
Yes.
That goes all the way back, starting with Gemini. And I remember George Lowe was so aware of this when he was a deputy administrator. And but it's been there, and it's something that you brought out very well.
Thank you. Thank you.
When I was chairing the NASA Advisory Council, this was something that came up, and the budgets that were being allocated for, and I'm not sure where that allocation came from, whether it was within NASA or the OMB or the Congress, but for this kind of outreach that you've described, were going down, and they probably are even lower now than they were then. And we raised that issue, and it was one that apparently was unresolvable. And my memory is not clear exactly, if I ever was clear, on why it was unresolvable. When Tom and I were active, NASA did have a reasonably good outreach program. If you weren't assigned to a crew, for example, there was your week in the barrel, and about every 8 months, we would be given to NASA headquarters and to fill requests from Congress and elsewhere for appearances. And so for a week, about 5 or 8 times a day, we would fulfill these requests all over the country. That was excellent. They also had a van, several vans, that would go around the country and visit schools and other facilities I was told hundreds of times how effective those vans were in outreach to school systems.
Yeah.
So it's not that NASA hasn't had a history of knowing how to do that. It's just that right now, my understanding, the budgets don't exist, and I know the vans don't exist anymore, and I'm not sure and I don't think that the week in the barrel exists anymore, because my understanding is if you want an astronaut appearance, the sponsor has to pay all the transportation, everything, all the costs. So if you want a better outreach program, the funds have to be there to do it.
Thank you. Thank you.
Okay.
Anyone else?
If I could just point out, NASA partners with museums all around the country. We touch thousands of kids every day through Boys and Girls Clubs programs. We reach kids in after-school programs. Our social media sites are some of the most popular in this country. But I would also point out that the way we get the most people engaged in NASA is Curiosity landing on the surface of Mars, the Pluto encounter. Every time you're going to see SLS launch, when we see commercial crew on its way to the space station, these are the ways we engage the public, by doing great and amazing things. That's our best outreach.
Well, and I think that's awesome. And I like to run their website where you can buy a ticket to the moon now. I mean, ticket to Mars. I went on and applied. I'm still waiting, 14 months, but, you know.
The gentleman's time has expired. Thank you,
Thank
Mr.
you, Mr.
Posey. The other gentleman from Florida, Mr. Webster, is recognized for his questions.
Thank you, Mr. Chair. Thank you for putting together this fantastic panel, the best one I've ever had in my whole time in Congress. Is this group. I've learned a lot. I would like to ask Dr. Schmitt a question. In your presentation, you gave quite a few items on the key to success of the Apollo program. And one of those was the sufficient base of technology. And my question is, what is that base knowledge, or is it hardware, or is it people? What were you speaking of when you were saying that you need a sufficient base of technology?
Well, thank you, Congressman. It's an important question. For Apollo, we had the component base of technology, the engineering understanding of many aircraft systems and some spacecraft systems that came out of the World War II and the Cold War, primarily out of the Defense Department. There was that kind of understanding. The X-15 program was an extraordinarily important part of the NACA, the National Advisory on Aeronautics activities that fed into NASA, both in terms of understanding flight in difficult regimes, but also because Bob Gilruth, who was the head of the Space Task Group, had managed and they were managing the X-15 program. So that knowledge, managerial knowledge, was a very important component. We also inherited the managerial knowledge from a Canadian aircraft program that was canceled by the UK, the Avro program. And many of the people that came into NASA, particularly in flight control, John Hodge and the like, were out of that Canadian Avro program. Gilruth made a specific trip to go up there and recruit. So that's what I'm talking, when I say a base of technology, it's not only the components, the microelectronics that were just coming on, some of the materials that were just coming on, but it's also, if you will, the technological understanding of how to manage complex programs. And now today, I think we're in much better shape, as I said in my testimony, than we were for Apollo. The base is much expanded, primarily because of the innovations in the private sector. The advance of computer technology. We were advancing it for Apollo, but all of a sudden it took its own legs and ran within the private sector. So that base right now, from the point of view of both flying and manufacturing, is so much stronger today than it was for Apollo. So I really think that if you all and others decide, let's go, let's focus, we're ready to move. I think we can make progress, and we can get up to a 2 heavy lift launch a year. In fact, that was probably the biggest mistake we made, and it started way back in the Johnson administration, is that we only bought 10 Saturn V's. And the Nixon administration confirmed that decision. We should have had that production line going continuously and launching a couple times a year, and we would have met that 2016 date without question. The Saturn V was a very robust system and could have done everything that we've done since and more. You got me started on something that.
Well, let me ask another question about the funding. I was thinking as we were talking about prioritizing, which I think is a great thing, and we pick our spots, and maybe all of them are laudable, but we can only do so much, and if we focus all our money there, then we'll accomplish the goal. Is there any thought that the other ancillary savings that come from the advances made by space exploration could just be funded from areas that we're spending, maybe futilely spending money on trying? For instance, someone said that every time there's a launch, there's a heightened interest in STEM education. Well, if that be the case, maybe we spend too much on getting consortiums together and funding those and trying to figure out how we're going to encourage somebody who's in the 7th or 8th grade to begin thinking about becoming an engineer or something else in the technology sense. maybe there's a broader prioritization that could take place. Maybe there's advances made in healthcare. Maybe there's advances made in other things, in technology, that come from space exploration that we're funding, but maybe we're funding and the results are way less than would happen if we were just doing that. Do you have any comments about that?
You know, the problems with funding basic research, whether it's in technology development or in scientific areas, is you really don't know where those spin-offs are coming from. Every year at NASA, we publish a spin-off book about this thick of spin-offs that have come off. If we could predict every one of those, I would agree with you. But the problem is we can't. And so when you're investing in basic research, basic science, basic technology, you don't know where the payoff is going to be. You just know there's going to be payoff because we've demonstrated that in this country for well over 50 years.
Anyone else? Yes.
Well, the one thing, again, all of us have talked about and the chairman has talked about is the stability, is that does not change between when administrations change. And when the first time this ever happened was when the Clinton administration came in, because, you know, it was President Reagan that started the space station, and that continued on. Well, President Nixon started the space shuttle, and that continued on, whether it was a Democrat or Republican. And then it started with the Clinton administration, and the next time it happened, bang, was with the last administration. And those two square waves really set us back.
Okay, thank you very much. Go back.
Thank you, Mr. Webster. And let me thank all of our experts for being here today. You could clearly tell by the participation and by the enthusiasm of our members that we all support America's initiatives in space, and you all have been a big part of that for many, many years, and I hope we'll continue to be a big part of that as well. So thanks again. Feel free to contact us anytime with your advice and counsel. We would look forward to that, and we stand adjourned. Thank you all. I'm going to go catch Rory real quickly. Okay. Thank you very